Hello. Today we are recording assignment 6.1 for our educational research class. And today we're studying the effects of chocolate on attitude over time. We have 4 observations in our data set. The attitude measured before the participant eats chocolate, the attitude measured 5 minutes after the participant eats chocolate, and the attitude at 1 and 4 hours after the participant eats the chocolate. So we can see that we have our 4 variables here. Now, because we have paired observations here, we can use a repeated ANOVA, assuming we meet the assumptions for the repeated ANOVA. So we're going to check those first. One of the first things that we will check is normality so that we can make sure we can run our parametric test. And to do that, we're going to go to Analyze and Descriptive Statistics and Frequencies. We want to check all of our observations to make sure all of them are normal. And we want histograms, and we want to show a normal curve. We don't need frequency tables. That would be a lot of tables with this many variables. And we're going to hit OK. And we're going to give it a minute to think. Okay. So we have all of our variables. We can see at the top, we have 23 values in each. Those should match. There shouldn't be any missing values. We have a histogram for each of these variables. So here is before chocolate, that's attitude 1 or attitude 0. Attitude 1 is 5 minutes out. Attitude 2 is 1 hour out. And attitude 3 is 4 hours out. All of these look somewhat normal. I wouldn't call them perfectly normal, but for the purposes of today, we're going to call them normal and proceed with a repeated ANOVA. So to run that repeated ANOVA, we have one more assumption to check, but we're going to check that while we run the ANOVA. We'll go to general linear model and repeated measures. We're going to call our factor time because time is the what we're adding over. We have 4 levels of time. We're going to add that in. And then we want to define those variables. We're going to move these over in the order in which they occur. So attitude 0 is before chocolate, 1 is 5 minutes, 2 is an hour, and 3 is 4 hours. And then we're going to hit EM means, and we want to bring time over and compare main effects. And we're looking at the Bonferry confidence interval adjustment. And then we're going to hit continue. We also want to hit options because we want our descriptive statistics and we also want effect size. And then continue. Now we've got all of our options in, and we're going to actually run the analysis by hitting OK. And it ran. We can see our descriptive statistics with means, descriptive statistics with means here in the middle of the page of all 4 of our observations for each person. And the next thing that we want to look at is the sphericity of our data. And we will do that by looking at our Munchley's test of sphericity. So if we see here, we have a test statistic of 0.860 with 5 degrees of freedom. And our significance value is 0.683. That's our p-value, which is greater than 0.05, our alpha. And so then we can assume that sphericity is met in this data set. And that is important because that's going to tell us which line to use in our next measure. Because once sphericity is met and normality is met, we would use the first line here underneath test of within subject effects. and instead of the second line. So if we're looking at the first line, we can see we have a test statistic of 5.681 with 3 degrees of freedom and a p-value of 0.002, meaning there is a significant difference between these 4 observations. So we know overall there is a difference. That just tells us there is a difference somewhere, but we need to know where is the difference. Is it between the before chocolate and after chocolate? Is it before chocolate and 2 hours out or 1 hour out? Where is that? So to look at that, we're going to come on down to our pairwise comparisons. And you can see multiple pairwise comparisons here. What we're looking at here, if we're looking at 1, that's before chocolate. And then we see the comparison or the test for 2, 3, and 4 comparatively. We can tell here that we have a significance value of 0.003. That is a p-value that is lower than 0.05, meaning there is a significant difference between before chocolate and 5 minutes after chocolate. There is not a significance difference between before chocolate and 1 hour out or before chocolate and 4 hours out. So we can tell that there is a difference there between the two means. If we look at 2, we wouldn't look at 2, 1 because that's we've already looked at that. So 2, 3, we see no close, but not a significant difference there. We do see a difference between 2 and 4 of 0.02. So there is a difference between 2 and 4. That means 5 minutes after eating chocolate and 4 hours later. In 3, we don't see anything that's significantly different. We would be looking at 3 and 4. And for the fourth one, we've already looked at all those values, but you can see that the 2 and the 4 is still significantly different there. The last thing that we may want to look at while we're looking at our test before we discuss results is the partial eta squared. So if we go back to our sphericity assumed line, we can see a partial eta squared of 0.205. If we use that as the effect size, then we could say that there is a large effect of chocolate on attitude. So how do we use this in real life? We can see in looking at our pairwise comparisons, there is a significant difference in attitude between before chocolate and 5 minutes after chocolate. After that, there isn't as much difference. So we would think of this as a spike in attitude, and then it slowly tapers back off to normal. Our means between 2 and 4 are positive, so we're seeing that attitude come back down actually after between 5 minutes after eating it and 4 hours after eating chocolate. How could we use this? If you're a grandparent and you need to hold off a cranky child for 5, 10, an hour until their parents come to collect them, chocolate might be the solution. And this will conclude assignment 6.1 for us.